This is the femoral popliteal right here.
Doctoral candidate Courtney Keiser dissects a peripheral artery which carries blood through the leg.
Once you've dissected it, you can kind of feel along the artery and you can feel any calcification. It's very hard and stiff.
The stiffness in the artery is caused by peripheral artery disease. It's a buildup of plaque, which narrows or blocks the flow of blood through the artery.
So 8.5 million adult Americans have peripheral artery disease. The total annual cost for hospitalizations for PAD is in excess of 21 billion per year. And that's because the need for reintervention because these devices fail is so high.
Commercial bypass grafts allow blood to flow around the blockage. However, they often fail within a few years.
So this is a commercial graft. This doesn't have any reinforcement to it, and so it pinches when it's bent. It's very stiff. You can't pre-stretch it, or there's no tension to it, where our bypass grafts are able to be stretched longitudinally, which more mimics the native vasculature of the femoral popliteal artery.
Keiser makes artery grafts out of electrospun nanofibers, which she creates in the lab. The nanofibers mimic the architecture of the real artery, encouraging blood and cells to attach and grow.
My bypass graft, you can stretch it, and then there's reinforcement incorporated within it to help prevent kinking. And so we can implant it with that inherent pre-stretch so that when you bend and jump and walk, it can accommodate those deformations without causing any tortuous behavior that would cause flow disturbances, where this one, we can't implant that with any pre-stretch to it. So when you bend, it's going to start to kink around.
Keiser hopes that one day her nanofiber grafts will mean fewer surgeries for patients with peripheral artery disease.